Great. All right. Okay. Welcome everybody to day 2 of the Pennsylvania virtual Turfgrass Conference for 2021. I want to thank you all for being here. So today is, again, like I said, is day 2. We will have 3 seminars today running 30 minutes each with about a 5-minute break in between. And at the end, from about 11:45 to noon-ish, we will have an open Q&A. And also then for your pesticide credits, if you would please, I've also hit in the chat window, if you would please put your name as it appears on your card, your state of residence, and also your certification number. Those will be quite helpful. If you don't have your cards with you, if you can find some way to get that information, that would be great. So, but otherwise, again, so then I went ahead and posted the instructions in the chat window. But again, please put your name, your state of residence, and your certification number for us to get you proper credit for the pesticide credits that will be awarded for these seminars.
Okay, with that, we'll just get started and jump right into it. I think Fidanz is having a hard time logging on, but we do have his talk, so hopefully he'll be able to get on prior to the end of it or after all 3 presentations are done. But let me introduce him. Dr. Fidanz is a professor of plant and soil science and holds a teaching and research appointment at the Penn State University located at the Berks campus in Reading. He teaches undergraduate courses in turfgrass science, soil science, botany, pesticide safety, and a graduate course through the World Campus program in turf physiology. His research projects include ecology, integrated pest management of turfgrass diseases and weeds, including farriering, which he's going to talk about this week, as well as plant and soil health in turfgrass ecosystems. At the Berks campus, he established Valentine East, a 30-acre turfgrass station modeled after the Joseph Valentine Research Center at Penn State. And he also serves as the director of Penn State Center for Agricultural Sciences and Sustainable Environment. So with that, let me share my screen and pull up his talk. I need to make sure I click that button. I don't know if I clicked it. Share my, I didn't. So that was good that I did that.
Be as informed as you can. So again, I hope that good morning, everyone. Welcome to the 2021 Pennsylvania Turf Council's version of our turf conference this year. This morning, we're going to talk about soil surfactant chemistry. I'm Mike Fidanza, and along with my colleague, Dr. Stan Koska, we put together a presentation on soil surfactants and the chemistry of the soil surfactant products. There's some degree of confusion in the marketplace about the active ingredients in these products. So hopefully we can shed some light on this topic. Now, soil surfactants are used extensively on golf courses and sports fields in the U.S. Now, again, the term soil surfactants, our industry refers to these as wetting agents, but for the purpose of this presentation, we'll use the term soil surfactants. And if you look at this survey from 2007, this is specifically for golf courses. Soil surfactants ranked #1 as far as products that are used to support water conservation efforts. This was in 2007, and if you look at this survey closely, soil sensors are at the bottom here at 1% response. This is early 2000s when soil sensors, TDR probes, POGO, were just starting to reach the marketplace. If this survey was done today, I suspect soil sensors would be #2, but still soil surfactants rank #1. So we're going to focus on again, soil surfactants and what exactly is a soil surfactant. Surfactant meaning surface active agent, right? But so what exactly is a soil surfactant? Well, this is from an article from 2012 and they in fact use the term wetting agent. Now the article, let's take a moment here, it's from the USGA Green Section Record, 2012 Zontech and Casca. This was really one of the first articles to try to shed some light on the chemistries behind these soil surfactants. The article is easily downloadable, and take a look at that when you have the moment. But in that article, they use the term wetting agent, which is any compound or any molecule that would cause the liquid to spread more easily across the surface or penetrate into a surface, basically thus reducing surface tension. If you take a look at this water droplet here, typical water droplet over a surface that forms this sort of droplet, but then what a soil surfactant would do is reduce that surface tension, if you will, and allow that droplet to spread out more easily. But again, wetting agent is a term commonly used in the industry where we're going to try to focus and use the word soil surfactant. So let's talk about the chemistry of water for a minute here. I think to understand soil surfactants, to understand the chemistry of these soil surfactants, we need to just chat for a bit about water, the water molecule itself, 2 parts hydrogen, 1 part oxygen. We all learned this somewhere in school. Now, there are different chemical bonds that make this water molecule unique, and one of the reasons why soil surfactants work the way they do relates to the water molecule itself. It's a polar molecule, meaning there's a positive charge on one side and negative charge on the other. And this is important to understand, again, how soil surfactant chemistries work. So let's talk about the physiochemical properties of water itself. Again, these properties of cohesion, adhesion, surface tension. Cohesion is very important. It's a force which allows the water molecules to sort of become attracted to each other. Cohesion is very important for and adhesion. All these properties are important for water movement in the soil, for plant uptake. The water needs to get into the roots, move up into the xylem, that kind of thing. But cohesion is very important in that the water molecules are attracted to each other, and it helps to form this water droplet. Adhesion is the water molecules itself attracted to a surface. That surface could be a soil particle, for example. And again, when wetting occurs, the adhesion force is more powerful than the cohesive force. In other words, we want, for proper wetting to occur, we want that water droplet to spread out and adhere to the surface, and we don't want the cohesive forces to hold that water together in a drop, so to speak. And the adhesion and surface tension sort of forces create this interfacial tension. It allows, if you look at a water droplet, it produces that, or facilitates the development of that sort of boundary layer, which is an intermediary between the fluid state of the water and the vapor phase of the outside environment. And so again, look at it this way: surface tension. You've seen a droplet of water on a leaf surface, for example, as in the photo, and you see the cohesion forces holding that water droplet together, the adhesion forces, that water droplet is sticking to the surface of that leaf. You have that boundary layer and the surface tension, again, forming that thin elastic membrane, which is an interface between, again, the liquid and vapor phase. So this is water molecule. This is the water molecule. This is how it works, and this is important to understand this as we talk about soil surfactants and soil surfactant chemistry. Now let's look at an example of these water droplets sort of in the real world. What you see here is a soil core, and you'll see these droplets of water placed along the soil core there, probably at 1 centimeter, sort of less than half-inch increments. Now this is the water drop penetration test. You take a water droplet and a dropper and just place one single drop of water along the edge there, and if the droplets of water infiltrate in, right away within 5 seconds, essentially you have a wettable soil. Okay. If it takes 5 to 60 seconds, basically a minute, you have a water repellent or hydrophobic soil, if it takes more than a minute, you're really getting into trouble here with some severe water repellents here, hydrophobic soils, root zone specifically. Again, this is a test that anyone can do, placing water droplets along the soil core and see how wettable or non-wettable that root zone is. So again, you can see the properties of that cohesion, surface tension, and then adhesion. That water droplet does not want to penetrate. Okay, so let's talk about this a little further. What is a surfactant? Now, surfactants, again, are considered compounds that essentially lower the surface tension or interfacial tension between two liquids, or gas in a liquid, or solid liquid. These surfactants, they're used in many, many industries, contact lenses, for example, contact lens solutions, and others. But these surfactants may act as detergents and wetting agents, emulsifiers, foaming agents, and other compatibilizing agents in various formulations and pesticide formulations and industrial compounds. But again, for our purposes in turf, the focus is on soil and the root zone. So what is an example of a molecule or a compound of what's considered a typical soil surfactant? So most soil surfactants, many soil surfactants, have what's called a block copolymer type of a chemical structure. You may have heard the term block copolymers, soil surfactant, or block copolymer surfactant. This is an example of an amphiphilic molecule. What does that mean? Well, amphiphilic means that the molecule has two sides to it, a polar side and a nonpolar side. A polar side means it's hydrophilic. It likes water. It helps to make things wet. A nonpolar side means it's hydrophobic. It repels water. It's water repellent. Hydrophobic, water hating, hydrophilic, water loving. Now what's interesting, and again in this typical block copolymer sort of molecule, again you have these polar sides, and then you have this sort of non-polar component to it, and the length of these chains can vary. If you're really into chemistry, you want to geek out a little bit, this is the sort of one version of the molecule. You have these ethylene oxide components, you have propylene oxide, ethylene oxide, and again hydrophilic, hydrophobic, hydrophilic parts to these molecules. Now these block copolymers, there are many block copolymer surfactants in the industry, available in our turf industry, but some are very similar, but some are not very similar. It's unlike a fungicides. There's so many different fungicides on the market, but we don't refer to all of them as fungicides. There's various active ingredients in these fungicide labels, so you just can't say all fungicides are the same. There are certain fungicides that control pythium, certain fungicides control dollar spot, certain fungicides control other diseases. The active ingredients, they can be all different. With block copolymers on the surface, you say, well, they're all block copolymers, they're all the same, and that's not entirely true, because these block copolymers can have different lengths of the polar sides or the non-polar sides, or components can be different lengths and can have different components to them. It's a lot more detailed than this. How do these soil surfactants then behave in soils? Well, what you see with a typical soil surfactant is, you'll have a hydrophobic center, or it may not necessarily be in the center. It could be to the right or to the left, or a different part of that molecule itself, and a hydrophilic component, a water repellent component, a water loving component. And typically what we want to see is the soil surfactant grabbing onto that soil surface, grabbing onto those non-wettable surfaces, and essentially having these sort of hydrophilic or water-loving tails interacting with soil solution and helping to essentially surround this hydrophobic surface with films of water. That's how we like soil surfactants to behave in soils, and this is typically how they do this. And not every soil surfactant does this very effectively. Some can do this slowly, some can do this more quickly, but there are various differences in how effective these soil surfactants are at behaving as surfactants in soils. Where do these water repellent materials come from? These hydrophobic materials. How do these root zones become hydrophobic or water repellent? Well, water repellent materials can come from various sources. Let's say, for example, these surface waxes of eroded, surface waxes from plants, from leaves, turfgrass leaf tissues and sheets, and as we manage turf, again with the mowing and the clippings, these become part of decomposing organic material and thatch. So you get various compounds that can, again over time, create water repellent conditions. Plant root exudates can contribute to water repellency. Fungal hyphae, fairy ring fungi, for example, but other microorganisms that create these biofilms that over time all lead to developing these organic coatings on soil particles. So again, this is as we manage turf, these sort of perennial pastures, if you will, these materials contribute over time to developing water repellent root zone conditions. And if speculating this in turf, we think that, well, I guess the majority of our water repellent materials most likely originates from decomposing organic matter in thatch. And again, that's why managing organic matter is very, very important for plant and soil health, but also at managing water repellency. Plant root exudates, fungal hyphae, etc. But these organic coatings, again, come from different sources as we're growing and managing turf. So if you look at this using electron microscope or micrograph, the sand particle on the right is wettable. The one on the left is not wettable. It's hydrophobic. Why? Because it has all those organic coatings on the surface of that sand particle. See all these organic coatings makes it very, very difficult to wet, and that's where soil surfactant can help. So another way to think about this is if you look at these organic coatings in a wet soil or a wettable soil, they're sort of weakly held on the surface, and you see the hydrophilic or water-loving part of that organic material is interacting with the soil solution. But as the soil dries down, as we dry down our root zone, what happens with these organic coatings, they become more and more hydrophobic. And the hydrophilic or water-loving part's trying to, it's being sort of suppressed by the hydrophobic part. The hydrophobic part is exposed, and that's repelling water. Makes it very difficult for roots to obtain water because it's being held too tightly against the soil surface. And so again, soil surfactants can help overcome this. So let's focus here a little bit then further on soil surfactant chemistry. Okay, soil surfactant products, they're made from several different classes of soil surfactant chemistries. And these classes of chemistries have molecules with different structures, and therefore different modes of action and how they interact with water and soil. Again, this came from the Zontek and Koska article, but it points to a very important point, and that is, again, these soil surfactant chemistries, they're all slightly different, and that's because they're slightly different, they interact in soil and water in different ways. So not all soil surfactants are the same. So what are the different types or chemical classes of these soil surfactants? So looking at types of soil surfactants or chemical classes of soil surfactants, that's the first way to sort of describe these kinds of products. And we can label them as far as chemical classes, one of 4 ways: anionic, cationic, non-ionic, amphoteric. These anionics, they are negatively charged, and they can offer fast wetting, but depending on the application rate, time of year, you got to be careful. These kinds of products can be phytotoxic to turf. They can, because of the negative charge here, they can impact soil structures in terms of dispersing clay particles. And again, on fine textured soils, this can impact with clay dispersion, this can impact soil structure in a negative way. Okay. Some of the older chemistries were the first soil surfactants in the market were the anionic groups. So then we have the cationic soil surfactants. These are positively charged. You have to be careful with these. They can be referred to as fire in a can. They can really injure turf. Visually, they can cause phytotoxicity. They're strongly adsorbed to the soil. And while they may, the first time you make an application with these, they might rapidly wet soils, but they can quickly make soils water repellent. So we don't really have cationic surfactants in the industry, but they may be used in production agriculture for other areas. Non-ionic surfactants, these are the ones that we use mostly in that turf industry. Again, they tend to be safer, especially used according to the label rates. There's no net charge. But most of our soil surfactants are in the non-ionic group, and again, they have this sort of polar and non-polar component to them as our typical block copolymer, like as I showed you before. And then you have the amphoteric surfactants that can be plus or minus charged, and these are not really commonly used either. So let's look at this again in terms of soil surfactant chemistry. You have a chemical class, you have chemical category, and formulation category. This is basically how we're trying to or attempting to organize soil surfactant chemistry in this way. Chemical class being non-ionic or ionic, chemical category, formulation category. Let's dive into this a little further. So if you look at this, this is from a recent publication, and we basically looked at the soil surfactant products in the United States. Basically, there's 192 total products in the marketplace when we put this information together. Now there's a little over 200. And first, let's look at chemical class. You have the non-ionic group here, and ionic, anionic, and then unknown. Now, of the non-ionic group, there's 142 products in the non-ionic group. Anionic makes up 18. There's 32 that are unknown, meaning the information couldn't be obtained from the label. Not every soil surfactant product has their information described on the product label. Some products could say proprietary blend or not disclosed. And I suspect most of the unknown products are probably non-ionic, but I can't be sure. Then let's look at chemical category. Okay. Of the chemical category, many of our block copolymer types, but then you have some of the alcohol and alkyl polyglucosides and botanicals and organosilicates, etc. Again, you go from the non-ionic, then you go to the chemical category. And again, let's focus on block copolymer here. Well, if you say, well, I have a block copolymer soil surfactant. Well, which kind of block copolymer specifically do you have? Do you have one that's just a straight block copolymer? Or do you have blends of different block copolymers? Are they blended with alcohol ethoxylates? Are they blended with APGs, malic acids? So you see what I'm getting at here. There's a great deal of information here that can be obtained, and a lot of this really you can't get from the label. So again, let's talk about chemical class, then we talk about chemical categories, and then we talk about formulation categories. So if you say you're using a block copolymer, great, but what kind of block copolymer? So again, looking at soil surfactants, we can't say all soil surfactants are the same because their chemistries can be very different. We even have biologicals here. We have, again, organic silicates, and there's others. So let's look at this a little further. At the soil surfactant U.S. turf market specifically, let's look at formulation categories. And when we did this, we had there was 192 branded formulations that we got information on, and today that's about 200. But if you look at this, the majority of the products really are these block copolymer types, okay? About half are block copolymers. And again, here's 17% that are just undisclosed, we don't know much about. These over here, some of these are patented, very unique molecules. And then you have some of the older chemistries over here, anionics, okay? But again, you see, even within the block copolymer group, there's so many sort of categories of these block copolymers, okay? So there's a lot of generic or post-patent compounds, molecules that make up the soil surfactant market. And again, when you look at these formulation categories, many block copolymers can be very similar. Some could be actually the same in different products, but different marketed with different concentrations. Could be 100% active ingredient in the jug. Could be 80%, 50%. You really have to kind of pay attention to that. So what's the commercial spin in the marketplace on these soil surfactants? Well, aren't all the soil surfactants the same? I mean, you could say, well, soil surfactants, they reduce surface tension of water, but beyond that, looking at soil surfactant chemistries, they're similar, but they're not all the same, of course. Can the soil surfactant really specifically place water? Can it hold water? Can it push water? What is a penetrant? Penetrant is not a correct term to use. Soil scientists do not use the word penetrant. In their world, there is no such term as a penetrant. Penetrants are reserved for adjuvants in production agriculture, but soil surfactants, we don't like to use the word penetrant. I really like to use the word retention agent either. Is it a water holder? Is it a water pusher? Again, what's a stripper? What's an organic matter redistribution aid? Again, there's all kinds of sort of spins in the marketplace, and really what we have to do is have to ask for data, ask for more information about these soil surfactants so you can decide if it's the better product for you to use. And again, more and more research is being done at various universities. So I like this question here. Aren't all soil surfactants the same? Well, this is from Dr. Cale Bigelow at Purdue, and he evaluated different products. Some are experimental, some are commercial. Let's call this product X at 6 fluid ounces, product Y at 5 fluid ounces, product Z at 4 fluid ounces. And you can see product Z here, turf quality is excellent. Product Y, there's localized dry spots developing. Product X, again, localized dry spots developing. So field efficacy trials are showing us here that while all three products are soil surfactants and all three are block copolymer types, they're all different in how they perform in the field in this particular field trial. Let's continue on. Are all soil surfactants the same? Well, this is a test of the it's called the water drop penetration test. And if you look at this, the particular soil that was used is very hydrophobic. The wetting time for this is over 3,600 seconds, over 5 minutes. Actually, longer than 5 minutes, and it's very hydrophobic. So what you do is you place a droplet of water onto this hydrophobic sand, and in the drop of water is the soil surfactant, in essentially 8,000 parts per million. That's a standard way to do this. And you measure the infiltration time or the water drop penetration time. Well, for this product, Excalibur, it took 4.3 seconds. For product A, product B, product C, these are industry standards. It took 27 seconds, 37 seconds, 26 seconds. All three products are respectable, but again, This is a new product, Excalibur from AquaAid, and it represents a new next generation block copolymer type of a product. Very excited. I've been testing this for a couple of years now. Very interesting to see this sort of new and improved sort of block copolymer technology. And there's definitely improvement in infiltration time, compared to these others. So again, not all soil surfactants are the same. And these, again, this is one laboratory test that we use to compare different products. Again, another example of a soil surfactant application on a sand root zone. This is from Ireland, and the soil surfactant was applied, I think, twice here prior to the photo. 4 fluid ounces per 1,000 square feet, okay, watered in. And if you look at this line, you can see where the applications were made to the left. Obviously, the application wasn't made to the right. And along here, there's an irrigation sprinkler head, and even though this area is watered to the right, you can notice the localized dry spot and the drought-stressed turf, whereas on the left, you can see improved turf quality here. So soil surfactants do, in fact, you could see a visual difference, especially during drought stress. And again, we talk about critical water content. It's very important to use these soil surfactants properly. When we have moist soil, we have good root to soil contact, great. But when it's dry, you see these films of water, they're held tightly around that soil particle. Roots can't get to it. We have hydrophobic or water repellent situations here. And this is where soil surfactants have to help us to overcome these dry zones. When we're drying the soil down too much, soils can flip, go from wettable to non-wettable very, very quickly. So soil surfactants, really, it's more about science than spin. Soil surfactants are used to manage localized dry spot and dry patch conditions, to modify soil moisture heterogeneity. In other words, soil surfactants can be used to uniformly help wet and infiltrate this root zone profile, increasing root zone water content, reducing runoff. Okay, using soil surfactants in a sort of a turf management program to help improve plant and soil health. Again, the market contains many generic products, which is fine. Okay, but ask for information, ask for university research, ask for company-sponsored research, ask for supportive data when you're using these products. Dive into it a little bit, ask if they have more information about their block copolymer types, and looking at their formulation category. Again, dive into this a little further and be as informed as you can. So again, I hope that this helped. Welcome again to the Turf Conference. Thank you for your time today, and enjoy a happy and successful 2021. Thank you.
All right, Danza, do you have the ability to show up and unmute yourself? I don't know if there's any questions here, but.
I'm not seeing any questions at the moment.
You want to remind people about how to put their information in, Brian?
All righty. So we're doing pretty well as far as getting your pesticide credit information. If you can, just in the chat window, if you haven't done so already, please put your name as it appears on your certification card, the state of your residence that you're spraying, and also then your certification number would be great. So name, state, and certification number would be great in the chat window.
Okay, well, I think Fidanza will be able to stick around to the end. So if there's somebody who does have a question about surfactants, actually there is a question, Mike. Somebody said, does Penn State have any data on the effectiveness of organic acid removal products and how effective they are? And I would probably relay that to not just Penn State, but any other. Mike, you're muted. I don't know if you have the ability to unmute yourself.
Well, I don't know.
Did he say anything in the chat?
I'm looking. Nope, nothing in the chat. We can save. Oh, do we have another one here?
We do, but let's just save them.
We'll save those for the open Q&A. But that's good. So we've got a couple of questions for you. So great.
Get your computer fixed, Mike. All right, let me bring up info on our next speaker.
I just got a text from Mike saying he got knocked off of Zoom. Let's see. So he got knocked off Zoom. I think he'll probably try getting back on if he can. So.
All right, that's fine. All right, I think, if I'm not mistaken, Ben's up next. So Dr. McGraw is an associate professor of turfgrass science at Penn State and an authority on the ecology and management of turfgrass insect pests. He obtained his master's degree in entomology from the University of Massachusetts in Amherst and a doctorate in entomology from Rutgers. Dr. McGraw's research focuses on understanding insect ecology and behavior to develop sustainable turf management, pest management programs. And today he's going to be talking about white grubs and European crane flies. So let me share my screen.
Hello, I'm Dr. Ben McGraw of the Turfgrass Entomology Lab here at Penn State, and today I will be providing an update on Hello, I'm Dr. Ben McGraw of the Turfgrass Entomology Lab here at Penn State, and today I will be providing an update on all things white grub management and European crane flies. We've had a couple of interesting years of weather, and that has largely led to what we observed at least at the end of 2020, at the time when we'd be seeing both of these two insect pests damaging turfgrass throughout the Commonwealth of Pennsylvania. 2020 really set itself apart from 18 and 19 in how exceptionally dry it was. And in the insect world, you know, drought is an absolute killer, but it more importantly really identifies not only weaknesses and possibly control, but really kind of makes apparent these populations that might have been going under the radar. However, we really need to go back to 2018, 2019 to see the full impacts of what moisture can do for insect populations. 18 and 19, at least from all of 2018 to half of 2019, was extremely wet, and we saw flooding in many places throughout Pennsylvania. However, what this allowed, this ample amount of moisture in the environment allowed for, was more places for insects that require moisture for their eggs to develop. So greater areas, larger population buildup, and then by 2020, when the spigot was turned off, so to speak, then we see where exactly these pests are problematic. Now, in fall of 2020, probably one of the most surprising things is the first insect that we'll talk about, which is the European crane fly. I was holed up in southern Maine this fall and really saw some spectacular amounts of damage. And this is damage that occurred earlier in 2020, believe it or not, in April and May, that just never greened up. Some very huge amounts of adult swarms we're seeing all across the region. I would contend from about Ohio all the way into the Canadian Maritimes. But that damage that we saw to that native area is caused by this stage of the insect. This is a European crane fly leather jacket, as more commonly known in European countries. I would contend that this is the biggest insect pest that we have on the rise in Pennsylvania. This is the adult, and many of you probably saw this on your properties. Is just massive, massive swarms that were reported all across Pennsylvania, all across the Northeast. These really kind of awkward Large flies, they are flies and they belong to the order Diptera, which are excellent flyers, but these really don't do a great job of flying. They're pretty awkward in that regard. It is also very important to note that there are many thousands of species of crane flies worldwide. There are only 2 of them that are problematic. Unfortunately, they are problematic in turf grass. So even if you do see a fly that looks like this in your turf, it doesn't necessarily mean it's a European crane fly. However, this fall, we saw huge explosions of 2 of our problematic pests. Those 2 problematic pests that we have are both of European origin. They have different common names. Unfortunately, we call both of them European crane flies. However, only one of them goes by the common name of the European crane fly. That's Tipula pallidosa. What you need to know about that crane fly is it's very, very traumatic to turf. It's one we don't want to have on our properties. However, it is not as well distributed as the marsh crane fly, Tipula oleracea. So there is a silver lining there. So the first thing that we want to know is whether or not, or which species we're dealing with. The European crane fly, as I mentioned, is one that we don't know as being in very many places in the Northeast, just some specific locales. Unfortunately, that's the Erie area in Pennsylvania. The common crane fly, I would contend we rarely have problems with it. However, we can see it on just about every place we look throughout Pennsylvania. One thing that we need to know is whether or not we're dealing with an invasive crane fly species, such as the 2 that I've mentioned, or if we're dealing with many of the hundreds of species that we can find here in Pennsylvania. So the European invasives, one of the things that you will notice about their wings is the forewing has a white band to it. And this is often hard to see without illuminating light from below so that you can really see that clear band. In this photo, I think it captures it fairly well. A lot of our native European crane fly, our native crane flies, I should say. Too bad we don't have editing in these things. But our native crane flies will have a great deal of coloration on their wings. So some of those cells on their wings will be darkened. However, these are fairly clear, with the exception of that kind of darkened forewing area and then that white band right behind it. Let's look at the 2 different species. Our first one is the common crane fly. As I mentioned, this one is in very many of the locales that we look at. All of our research sites all across the Commonwealth seem to have these things flying around in spring and in fall. So the marsh crane fly is native to more central and southern Europe. It does occur in the British Isles as well, but it can handle these drier environments. Both of our crane flies and really all of our crane flies are really attracted to moist conditions. This one, what you can see here, the wings are larger than the abdomen, and this gives this insect the ability to disperse further distances than its counterpart, the European crane fly. So if it can fly, and both of these species are going to be mated pretty much as soon as they come out of the ground, they're going to deposit those eggs within 48 hours after coming out of the ground as an adult. If it has the ability to move greater distances, it's going to place some eggs here, some eggs there, and they're not all going to be clumped together. And so that's really the biggest implication that we have with the ability of this insect to disperse. So we can see it in a lot of places, has the ability to persist in dry and wet places, but very rarely do we ever see it become problematic. So those wings are very, very important. The other important thing to know about this insect is it has 2 generations per year. Now, naturally, one would think 2 generations per year, that's got to be twice as bad as an insect that has 1 generation per year. But that's not the case with this insect. What it is important to know is it's going to go from egg to adult twice in the year. That means we're going to have the presence of these flying adults 2 times throughout the year. That's in spring and fall. So this was from a GCM article more than a decade ago, but I think this seasonal account is very important to know when we could expect these different stages. What we see in maroon is the Marsh Crane Fly. So as I mentioned, it has 2 generations per year. It's going to be larvae are present in the soil right now in the wintertime. They're going to pupate. They're going to emerge as adults in spring, lay their eggs, and then pretty much just hang out for the entire summer in the soil in kind of a hibernation state, if you will, before it's going to pupate and spring forth adults yet again. So the 2 times of the year that we would expect to see these adults, and really everybody was very aware of the adults that we saw in the fall, this species might have gone undetected or unnoticed because it wasn't in such high amounts in the springtime. But it will have flights typically at the end of April in the Pittsburgh area, all the way as far as early June sometimes. But it should be fairly synchronized by location. The European crane fly here in blue, what you can see is most of the year it's in the larval form. So eggs are laid in early October and they're going to persist as larvae pretty much up until the end of September, where they will then pupate and adults will swarm. So what you can see from this graphic is that both species will be flying in the fall. And that's where we saw our major flights. It could have been one species, it could have been both species. It's just very impossible. It's very difficult to tell. However, in the springtime, if we do see major plumes of these adults, we can be assured that that's the marsh crane fly or possibly some of our native species. This is the insect that I'm most concerned about. This is a female European crane fly, the European crane fly. So Tipula pallidosa, you can see its wings are basically the length of its abdomen. So this female here, when she comes out of the ground, out of her pupal casing and is mated immediately, she is loaded up with eggs and has a very difficult time getting off the ground. And so because she has this difficult time getting off the ground, her eggs tend to be deposited in a very localized pattern, not far from where she probably emerged from her pupal casing. So those wings, again, they're very clear. You can see it's difficult to make out the white band without that illumination from below. You can see the darkened forewing that and a couple of cells in there as well. Where are these species problematic? Prior to 2020, we would say that Tipula pallidosa, again, which is my main concern for turfgrass managers in the state, was located pretty much in Erie and a couple of surrounding counties. We had confirmed cases from one of our research sites in Mifflin County, which is to the east or the southeast of State College. And also I would contend that these large flights that we saw, it's most likely that this insect has spread out. That could have happened through the movement of sod. It could have happened through storms moving these adults on the wind. But most likely the huge amount of rainfall that we saw in 2018 and 19 just allowed for these populations to expand outward and outward and outward. So this is one insect that we do believe is going to be showing up in more places, and one that we want to be aware of in springtime as the major amount of damage occurs in spring. So the million-dollar question that everybody wants answered is, are we going to have some severe damage from these leather jackets? Now, this is the stage that causes the damage, and it's the stage that we should be most concerned of. But, we saw huge plumes of adults. One, we're not really sure unless we have a sample that's brought to the lab or really good photos where we can identify them to species. We just don't really know what the future holds. However, we can give you some tips about how to monitor for these insects and really have your eye out for some of these problems. I will say the spoiler alert is there's lots of products that control leather jackets. It's really about whether or not you need to control them. So one of the things that we can see with this insect is that it is very much dependent on moisture. And that is a good thing as far as turf grass managers go in Pennsylvania, that these populations typically surge in years where, we have adequate rainfall, very problematic in the British Isles. And then we see these populations crash in the British Isles in times where we have drought. So this is exactly what we had just recently seen here in Pennsylvania. However, from our trials that we conducted in Erie in the fall, even that drought right around egg hatch, I thought would really kind of choke out their populations. We saw some fairly large larval populations in our research sites. So it is something that we are monitoring. It's something that we are concerned about. Hopefully we do get a little bit of relief from Mother Nature. All right, so what to look for and when. Again, we've already talked about the adult flights. Marsh Crane Fly, we would expect them in spring and fall. European Crane Fly in fall. So moving forward into the springtime, again, I'd be looking for adult flights. If we are seeing primarily, seeing large amounts of adults flying in springtime, it has a high probability of being the Marsh Crane Fly. We could also use these tips in fall to look for Tipula pallidosa, the European crane fly. What we can look for is the pupal casing sticking out of the turf. So on, anything from fairway height and lower, you will see these pupal casings sticking out of the turf on the day that the insect emerges from that casing. Pretty much from that time period where you see those twig-looking cocoons, if you will, sticking out of the turf, it's about 48 hours for that female to drop her eggs. More likely in high populations, like many of you probably saw this fall, is you'll see swarms of adults. Again, they're not great flyers. They're just going to move up in front of your mowers. But riding a cart through an area, riding a mower through an area, all types of turf can be affected. All turf situations can have crane flies. So in really high density populations like we've observed in 2020, they're going to make themselves very, very apparent. Another thing that we might see is adults mating, and they tend to congregate on white surfaces, white buildings, and they'll be paired up like this for quite a bit of time. So in high density populations, it's not difficult to find these. If we see them in the springtime, and we can get samples to the laboratory or good photos, we can possibly determine whether or not that is the common crane fly. So really the most important thing is when would we expect to see damage? And that's going to be slightly different between the two species. Both species have 4 larval instars. So what we need to be thinking about is when is the insect really going to feed most voraciously? When is it going to be a size that is going to cause considerable damage? Basically, when is it a teenager going to an adult? So that's when the insect is going from its second to last, or its penultimate instar, to its last instar. So when are the insects between 3rd and 4th instars is when they are going to consume the most amount of food. If we see that damage in the springtime, and this would be about the time of April or May if we're starting to see turf loss, again, I would be looking in wetter areas. If we see that not responding and there's ample moisture in the environment, it might be worth probing the soil with a knife or a cup cutter. This would likely be the worst scenario of the 2 European crane flies. Tipula pallidosa is moving from a 3rd instar to a 4th instar in springtime. Now the common crane fly spends the winter as a 4th instar and doesn't need to feed in springtime, but it's going to have 2 generations per year. So where we would expect to see damage would be at a very different timing from the European crane fly. So on the lookout for those of you to really kind of let us know whether or not Tipula pallidosa is in your area would be the advent of damage in springtime. All right, where would you look? I mean, what we know mostly from studies in the United Kingdom is that eggs are really deposited in moist environments. So it's, again, if we see the pupal casing sticking out of the turf, we've got about a 48-hour window when most of those eggs are going to be dropped. It's going to take 2 weeks for those eggs to hatch. And in that time period, these eggs really need to be in saturated, wet environments. And so areas that are prone to pooling of water, thick areas of rough with heavy soils that retain moisture are all very problematic areas and places that I would scout and be on the lookout for. Here's a soil core from some of our sites where we have consistent European crane fly problems. And you can see that the thatch is very, very difficult to separate the turf from the soil here. Very thick and thatchy areas. One of the things that we recommend for those of you who are dealing with European crane flies is really kind of diluting the thatch, poking holes, at least pulling a cord, somehow trying to minimize that type of damage. Things like injecting sand is a great area, for, any low fairway area. Typically what we don't see, which is a good thing in North America, we don't typically see the amount of greens, putting green damage that is experienced in the UK. So in the UK, pastures, athletic fields, really all turf areas, just like in the United States, can be prone to damage from crane flies. However, really where they get it worse is within the putting surfaces. And to me, that suggests that all of the cultural practices that we put into the intensity of those things in putting surfaces really has an impact on things like European crane fly density. However, one thing that's important to note is that looks definitely can be deceiving. This was a turf plug that was as healthy as could be, that had many of these maggots in them, 100 larvae per square foot, or 10 larvae per cup cutter, if you want to conceptualize it. They come to the surface, they'll rasp the foliage, they'll feed on the roots. The damage can be very severe in big areas or in dense areas. But what we can also see is that these densities don't always equal damage. This allows them to really build up over time. All right, so as far as management goes, this is more of a PSA, a public service announcement to be on the lookout for these things. I am concerned about the European crane fly showing up in places where we didn't know it was around, such as our Mifflin County sighting. But really, detection is the first step, and then the second step is really assessing whether or not you need to take control. This was a pretty bad, rough area where it struggled on this golf course. However, it was also at a time of great drought. Other than the nuisance flies that were flying around, I'm not too sure that golfers were concerned about the turf burning up or not. So really understanding, prioritizing your areas with European crane fly, assessing whether or not you even need to take control. If you have determined that this is a problem, and again, I think in spring we're going to be in a wait and see type of situation as far as what has carried over from 2020. But really the best time to control these insects, and oftentimes golf courses or athletic fields will have both species present, the best time is in the fall. They're both going to be small larvae at that time, and there's lots and lots of products that work very well. Things like contact insecticides that are more cost effective than some of our systemics. In the springtime, these larvae are they're either going to be third or fourth instars. That's a large maggot to try to control. It's going to be very, very challenging to do so. If we are at that point where we know we had problems, we saw lots of flies, we're concerned about damage. Again, our research has shown that it's very difficult to get adequate suppression of leather jackets in the springtime. But in fall, again, lots of things work very, very well. We have systemics, things like acelepryn, chlorantraniliprole. The neonicotinoids seem to work very well, especially in combination with pyrethroids. But as I mentioned, there's lots of things like these, contacts, flamethrowers, Carbaryl seems to be the one of choice. We don't see great control with it in our trial, but I know many turfgrass managers do. Organophosphates like chlorpyrifos. But really, what we saw as far as our best control in our fall trial, when we can time it appropriately in the beginning of October all the way up until probably about November, when the larvae are still in the first or second instars, are the pyrethroids. Very cost effective, very effective. Our combination products like Triple Crown also very effective. Those have two pyrethroid components along with the neonicotinoid. So lots and lots of options, especially in fall. Again, this might be a wait and see type of thing for the spring. All right, so that brings us to white grub control. What's new in white grub control? As you can see from this photo from the 1950s, we're still pretty much entrenched in chemical warfare with white grubs. I would say also because of some of the chemicals that we have used and in the success of these products, there hasn't been a whole lot that has changed in white grub control. I would also contend 2020 was not a bad year, even though we had ample moisture for a couple of years, and really two pretty severe white grub years as far as what we have seen in our laboratory and the trial visits that we've conducted across the state. 2020 seemed to be fairly benign. That might have been in part to the really excessively dry conditions that we had during that egg laying window of really July all the way into August, into the beginning of September. So populations in total were fairly light. However, things also, our controls also have been working very well. A large part of why it's been quiet on the grub front is this class, the Anthronilic Diamides, which were developed in the 2000s. Really, if you think about imidacloprid being developed in the 90s and the success of that product, and then these products, there's very little need to develop alternatives for many. So the Anthronilic Diamides, we know them as aceleprant and ferrants, chlorantraniliprole and cyantraniloprole. These have very long residual activity. Aceleprant's really the gold standard in white grub control right now. It's virtually non-toxic to pollinators, so that's a really nice benefit to these products. Very low mammalian toxicity, if any, basically because of its unique mode of action. And we can really get season-long white grub and caterpillar control with an application. So, here's some of the data that we've had from our trials. Our trials with any of our preventives, any of the products that we put down before egg laying really look exceptional. I know that, whenever we look at these products in a very controlled trial situation, they always look dynamite. This was a trial that we conducted last year with Syngenta, with aceleprant, looking at timings as early as April, which I never thought was something that I'd ever recommend. And what you would think is that you want to put it down, give it enough time to get into the plant and be there as those larvae hatch out of the eggs. And we still want to do that, but really some people have questions about timing. If we look at two different formulations, the SC, so a liquid versus a granular application, we can see some formulation differences. The liquid, it didn't seem to matter when we put it down. We got about 100% control, either in April, May, or July timing, which would seem to be pretty late in my opinion. So this trial, very simple, but very, very informative. With the granular, it actually looks better the earlier you get it down. So it's something to think about, especially if you're using granular applications. Our imidacloprid also looks really, really good. However, that preventive, I want to put closer to that mid-July egg hatch. So I like to put down the imidacloprid at least in June, if not all the way up until about the middle of July. This could be affected by weather as well, but for the most part, these things are steady as ever, looking pretty good. So really, the newest thing is not actually currently registered in the United States. It's available in Canada. but it will be coming very soon, I believe in 2021. It's going to be rolled out, is Tetrino, a new product from Bayer, which is tetraniliprole, which is another anthronilic diamide in the same vein as Ference or Acelepryn. We've only done a couple of trials with white grub, so dating back to 2015, what we had were a couple of different timings. So we had 3 applications, May, June, or July, which was before egg laying, and we also had a curative application in August. And what you see here is, unlike the other anthronilic diamide data that I showed, we didn't see great control until we got closer to that egg hatch. So this is probably a little bit more similar to something like imidacloprid or merit, where we're not putting it down in April and May. We want to get it closer to that egg hatch. In 2019, we had again, this is what we do on campus, where we artificially seed in these beetles, really high control, high density of eggs in there, high density of larvae, and we got 80% control in July. So very, very good control. 80% is great in 2019. All of our data on all of our different insect pests seem that this anthronilic diamide is a little bit different than Acelepryn or Ference. And what really seems to stick out to me is the curative activity of this product. So we did do a trial this year that I haven't shown, that we're just summarizing the data with a curative white grub trial, and it did seem to have some very excellent control in September when those larvae are already apparent. I had some data from the EPA sent to me from somebody who deals with these types of data to really look at the 3 anthronilic diamides. And, I don't need to go through all of these things like soil adhesion and all of these things, but it does seem to bind to the soil fairly tightly, a little bit higher than something like Acelepryn. It's systemic. It degrades about the same. Looking at its degradation properties here, in the soil, the aerobic soil, soil DT50, it's going to be somewhere between a Ference and a Acelepryn. It's really not going to give us, I don't believe it will have the residual activity that something like Acelepryn has, and our data would support that as well. One thing that does stick out to me is really this bee toxicity down here, the bee apis contact LD50. This is more similar to Ference. So if we are using this product, just like if we are using Ference, we want to water it in and not have any sort of drying on the leaf. With Acelepryn, it's virtually non-toxic to bees, so less of a concern there. So you could either use granular formulations if they are going to have granular formulations, or if it is a liquid, we want to water it in, get it off the leaf. All right, so some of the things coming down the line as far as white grub control, obviously Tetrino's a big one. Something that I don't know if it's gotten enough mentioned, but I have to imagine that Acelepryn is going to be coming off patent sometime soon, which would possibly lead to generics. I think Tetrino coming on the market might drive prices lower regardless, but all that competition is a good thing for you, the consumer. We also have some concerns about imidacloprid's future, and I've been giving these talks about imidacloprid's future for quite some time now. So I don't know how much stock I take in this as well, but I do believe that the EPA is considering banning liquid applications for home lawns, which we know if we don't water them in can have some pollinator issues. But this does not seem to be a pollinator-driven thing, but rather an exposure issue. So as far as imidacloprid's future, we really are waiting to see whether or not companies are going to be supporting these labels, or if we're just going to move solely to a granular application. The granular is just as effective. It's just poses less issues for exposure as well as pollinators. All right, so that's what I have for European crane flies and white grubs. I will take any questions. In case you're wondering, that is a whole bunch of leather jacket maggots cooperating to spell out the word thanks. So I thank you for your time. And I want to put up my contact info there, which is blocked out by my head. But definitely all the support that we've been given, especially Pennsylvania Turfgrass Council. All right, thank you for your time.
All right, we have time for questions if there are any. Fidanza, are you back on here while we're waiting for any questions that somebody might have for
Yes,
Ben?
yeah, I'm here.
If anybody has any questions for Ben, just type them into the Q&A. But Mike, there were a couple of questions that you answered in the Q&A, but maybe you could read the question and your answer.
Yeah, the first question was about the organic acid removal products and soil surfactants. There has been research that looked at these organic acid removal products and showed a reduction in organic acids in column studies, but the data is quite variable. Some products work better than others, and I think the one product where they're thinking about is the ORS HS and ORS PS. That manufacturer, they do have some data to support reduction in organic acids when you use the materials. But I want to caution the folks, use that product as a very good soil surfactant, but that's not a magic cure for reducing organic matter, thatch accumulation, that kind of thing. It's part of a good soil surfactant program, but as far as managing organic matter, there's other things you have to do with that. Let's see, what was the other question, John? It was on, let me see, here it is.
It was temperature, I think.
Oh, temperature, yeah. No, none of the research has indicated its temperature affects soil surfactants. I know folks over there in Northern Europe and in the UK, they like to use soil surfactants for late fall, winter applications, as well as spring and summer. So as long as the soil surfactants are watered in, temperature doesn't seem to have an effect on them. The only thing you might want to watch on those soil surfactants that I've seen in the jug, if they're in a pesticide storage facility, make sure it's temperature controlled. If it gets freezing temperatures, sometimes those products can turn into a gel. But that goes with any pesticide, really. So, keep it, make sure you don't keep the products frozen when you store them, that kind of thing. But as far as applications in air temperatures or soil temperatures, they're fine as long as the products are watered in. If that makes sense.
Yep.
Yeah,
I don't
thank you.
I don't see any other questions at the time. Ben, are you going to be able to stick around to the end in case people have a couple questions?
I am, but I would say that speaks to the completeness of my talk compared to Mike's.
Hey,
I'm
Ben.
sure Pete will have a lot of questions.
Ben, actually, I've got a question. I was mowing fairways a couple of summers ago at one of the golf courses, and I had birds continually just kind of flying in front of the fairway mowers. Is that an indicator? Are they chasing some kinds of insects or something like that? Or?
Yeah, absolutely. I mean, it could be earthworms as well, but yeah, I mean, we often watch, we'll artificially seed in a bunch of beetles into our plots, like on campus at LMRC. And it's kind of infuriating. You see these birds come in and start working it. So, they're not just randomly probing. I think there's probably something below. So that can be a really good indication, especially where moisture follows too. Great observation, Brad.
All right. Our next speaker, let me get the bio up here. Our next speaker is Dr. Lanscoot. Pete Lanscoot's a professor of turfgrass science in the Department of Plant Sciences at Penn State. His primary responsibilities include turfgrass extension, research, and teaching the case studies courses. His current research interests include turfgrass weed management in naturalized grass stands, soil fertility, and fertilizer use, as well as warm and cool season species and variety evaluations. So with that, let me get your talk up here.
Good morning, everyone. I hope your new year is off to a good start. The topic of this presentation deals with managing weeds with cultural practices and herbicides in naturalized grass areas. I think just about everyone in the golf industry knows that the trend of establishing infrequently mowed stands of grass, often referred to as naturalized grass areas or native areas, on golf courses has been steadily growing over the past 2 decades. Some reasons for this relate to aesthetics and golf course design, whereas others focus on reduced labor and resources, including water, fertilizer, fungicides, and mowing. With budget reductions and labor shortages plaguing some golf course operations across Pennsylvania, it's not surprising that more areas are being naturalized on golf course properties. However, naturalized areas can also be a maintenance challenge for golf course managers, and one of the biggest challenges is keeping weeds to a minimum. In this presentation, I'll discuss some cultural and chemical methods for managing weeds in infrequently mowed grass areas, including species selection, establishment timing and methods, mowing practices, and herbicide selection for annual and perennial weeds. Species selection is an important consideration in the aesthetics, playability, and management of weeds in naturalized grass areas. In our region of the country, most golf course designers like to use fine fescues as the main species for naturalized grass areas. At certain times of the growing season, the brown, wispy seed heads of non-mowed fine fescues impart a natural look to the course, reminiscent of the classic links courses in coastal areas of the British Isles, where fine fescues are naturally adapted. However, there are substantial differences between maintaining an aesthetically pleasing and functional stand of fine fescues in coastal areas of the British Isles versus Pennsylvania and most other regions of the United States. Cooler temperatures, low light conditions, and sandy soils in places like Scotland favor fine fescues over other grasses, including weed grasses. Taking all these factors into consideration, it's no wonder that fine fescues are used extensively for roughs, fairways, greens, and tees in northern Europe along coastlines and require relatively little maintenance. In Pennsylvania, poorly drained, nutrient-rich soils allow fine fescues and other grasses, including weed grasses, to grow rapidly, and stands become extremely dense and weed-infested. Heavy summer rains cause lodging, and temperature extremes lead to disease and other problems in infrequently mowed areas. Hence, occasional mowing, thinning, removal of stem and leaf debris, as well as herbicide applications may be needed to keep naturalized grass stands in good condition. In long-term research trials at Penn State, we looked at 15 different cool season grass species and 4 warm season species for use in naturalized grass areas. About half of these grasses did not show good long-term performance. The cool season grasses that did perform well with respect to persistence and competitiveness with weeds included 6 fine fescue species, tall fescue, and hybrid bluegrass. 1 warm season species, little bluestem, also performed well when mixed with fine fescues. Of the fine fescues, hard, sheep, chewings, and creeping red were the most persistent, aesthetically acceptable, and most available in mixtures used for establishing naturalized grass stands in the Northeast and Mid-Atlantic regions of the United States. Creeping red fescue performs well in most regions of Pennsylvania and is an excellent grass for weed suppression, the best of the fine fescues for this purpose in our trials. Most cultivars of this species establish a bit faster than the other fine fescue species and tend to become quite dense over time. One of the knocks on creeping red fescue is that it is not conducive for finding or striking golf balls. However, in my discussions with golfers, they tell me that all the fine fescues can become too dense to hit from, and if that's a concern, these grasses should be mechanically thinned and mowed on a regular basis. Although creeping red fescue is present in some fine fescue golf course rough mixtures, it is usually less than 40% by weight. By itself, creeping red fescue is probably best placed in areas well out of the way of active play and where weed suppression is needed most. Hard fescues are relatively heat, drought, and shade tolerant when grown in non-mowed stands. Foliage of hard fescue is typically dark green, whereas the seed heads are light brown, contrasting nicely with the dark green ground cover. Hard fescues are somewhat slower to establish than chewings and creeping red fescue. However, they can make vigorous and sometimes excessive growth in fertile soils. This photograph shows an extensive planting of hard fescue behind a bunker on a Pennsylvania golf course. Plantings around bunkers are not my favorite location for hard fescues, but the photo shows the growth habit and weed suppressive characteristics quite well. Although hard fescue performs well in many locations in Pennsylvania, a few of our trials in central Pennsylvania have shown occasional thinning and decline of some cultivars in early spring following late fall mowing and cold winter temperatures. Sheep fescue is also heat, drought, and shade tolerant in non-mowed situations. This photo shows Marco Polo sheep fescue in a partially shaded rough at Baltus Road Golf Club. Sheep fescue foliage has a blue-green hue, and its golden seed heads provide nice contrast to otherwise uniform green fairways and roughs. Like hard fescue, sheep fescue is somewhat slower to establish than chewings and creeping red fescue. Sheep fescue cultivars have performed well in our trials and appear to do well in all regions of Pennsylvania. Chewings fescue cultivars typically have lighter green foliage than hard fescue and produce attractive light brown seed heads that tend to be taller than those of hard and sheep fescue. This species grows well in most areas of Pennsylvania, and like creeping red fescue, can become quite dense in fertile soils. Chewings fescue is a common component of seed mixtures used for naturalized grass stands, typically between 20 and 40% of the seed mixture based on seed weight. Tall fescue is less popular as a species for naturalized grass stands due to its coarse texture and the fact that golfers find it difficult to play from when dominant in non-mowed stands. However, this species is persistent, heat and drought tolerant, and competitive with invasive weeds. Tall fescue also produces aesthetically pleasing seed heads when viewed from a distance. Tall fescue is not compatible with fine fescues, and in my opinion looks like a weed when plants become isolated in an otherwise pure stand of fine fescue. Generally, there is little advantage in mixing other grass species with fine fescues in naturalized grass areas. However, one species native to North America, little bluestem, has performed quite well in our trials when mixed with fine fescues at low seeding rates, about 10 to 20 pounds of little bluestem seed per acre. This species grows taller than fine fescues and produces an attractive red color in late summer and fall. One problem that may be encountered with native grasses with respect to weed control is that some are susceptible to the effects of herbicides used to control perennial grasses. This is an area that needs more study. If wildflowers are incorporated with the mix for color and diversity, golf course managers should be aware that herbicides used to control broadleaf weeds such as Canada thistle and goldenrod can take out desirable wildflower plants like butterfly weed. Timing and method of establishment can have a significant influence on weed encroachment in new stands of fine fescue. Generally speaking, late summer and fall establishments are less prone to invasion by weeds than spring seedings, as shown in this photograph, especially for summer annual weeds like crabgrass, goosegrass, purslane, and spurge, as well as some perennial weeds such as nutsedge. If you do have to seed fine fescues in spring, options for controlling crabgrass and goosegrass are somewhat limited. Siduron, or tupersan, can be applied at seeding and will provide some crabgrass control, but it typically has limited efficacy when crabgrass pressure is high. Also, it does not control goosegrass. Some people have used mesotrione, or tenacity, for summer annual grass control, but this herbicide is not labeled for use on new fine fescue seedings. This slide shows that tenacity at the low rate of 5 fluid ounces per acre can result in minor stand thinning if used at the same time hard fescue was seeded. We have found a similar response with quinclorac, or Drive XLR8. It's likely that the safest program would be an initial 2% application, followed by a post-emergence application of tenacity a few weeks later when the fine fescue is mature. This is another area that needs some more research. Although there are different ways of establishing fine fescues, we have had good success when the entire site is scalped and then treated with glyphosate in August. Following death of the turf, a good practice is to core aerate the area twice with half-inch tines. Following aeration, the area can then be sliced in 2 or more different directions prior to slit or broadcast seeding. Getting a fast establishment of fine fescue is essential to compete with annual weeds. Depending on who you talk to, there are different ideas about seeding rates for fine fescues. Our research at University Park and Longwood Gardens has shown that seeding at 4 pounds per 1,000 square feet provides an adequate stand that is fairly competitive with weeds. Starter fertilizer will help speed establishment, but once grass covers the soil surface, fertilization should be curtailed. Some golf course renovation projects have used fine fescue sod as a means of establishing naturalized areas. Although considerably more expensive than seeding, this method offers an advantage of establishing fine fescue quickly with little or no weed competition. This slide shows the results of an establishment trial in which different species of fine fescues were seeded at different rates. After 4 weeks, creeping red fescue seeded at 4 pounds per 1,000 square feet, shown in the left rear plot, provided the greatest ground cover, where sheep fescue seeded at 4 pounds per 1,000 square feet in the right rear plot showed less cover, indicating a slower establishment rate. In fact, the sheep fescue seeded at 4 pounds per 1,000 square feet had a similar ground cover to the 2 pound per 1,000 square feet seeding rate of creeping red fescue. This demonstrates the effects of seeding rates and species on the rate of establishment and indicates why creeping red fescue is included in some fine fescue seed mixtures. This slide shows the same plots as in the previous slide during the spring following fall seeding, but looking in the opposite direction. The 4 pound per 1,000 square foot seeding rate for creeping red fescue is in the foreground on the right, and the 4 pound per 1,000 square foot seeding rate for sheep fescue is in the foreground on the left. A severe infestation of Poa annua has occurred in the sheep fescue plot as a result of the slow establishment in fall and lack of competitiveness with this winter annual weed. Because of the extensive Poa annua contamination problem, I thought I was going to have to terminate this trial. However, by May of the second year, I could not find any Poa annua in the test area. Basically, all the species and cultivars in this trial outcompeted and shaded out the Poa annua. Sometimes a little patience pays off when it comes to managing non-mowed grass stands. Periodic mowing can improve aesthetics of naturalized stands of grass, and over the long haul can suppress certain tall-growing weed species such as Canada thistle, American burnweed, milkweed, pokeweed, as well as various tree and shrub species if done at the right time and frequently enough. To keep naturalized areas in grass and reduce encroachment of tall-growing weeds, the areas must be mowed at least once per year. Many, if not most, naturalized grass stands in Pennsylvania are mowed only once per year in late fall. Golf course operations with adequate labor and equipment may mow 2 or 3 times per year. The number and timing of mowing varies depending on the experience of the manager and the effect desired. But early to mid-spring, after seed heads dissipate in late summer, and when the golfing season ends in fall are most popular and beneficial. Mowing after lodging occurs following heavy summer rainstorms can improve the appearance of the stand and prevent smothering of tillers beneath the fallen stems. Increasing mowing frequency from 1 to 3 times per year may not reduce the total number of weeds short term, but our trials have shown that tall growing weeds such as teasel, perennial sow thistle, and burnweed are less visible, as shown in this demonstration trial at Longwood Gardens. Keeping weed populations to an acceptable level in naturalized grass stands with no herbicides is very difficult, so sometimes applications are justified, even though most people want to minimize pesticide use in these areas. Encroachment of different plant species is part of the natural succession of a non-mowed grass stand, and keeping out all invaders is unrealistic. In fact, some golf course managers let nature take its course in these areas and don't devote a lot of effort to controlling weeds. Many other managers attempt to control some of the more invasive and objectionable weed species in non-mowed grass stands. Deciding which species should be controlled or suppressed and which species can be left alone depends on the expectations of golfers and the judgment of the manager. Some weeds, such as milkweed, butterfly weed, aster, and Queen Anne's lace, are desirable when present in small populations, as they enhance the appearance of the stand, attract pollinators, but don't interfere much with play. Other weeds, such as Canada thistle, quackgrass, Japanese stiltgrass, nutsedge, and foxtail, are more aggressive and can spread rapidly, taking over large portions of the stand. Thus, managers need to determine which weeds are problematic and then decide what, if anything, to do about it. If you can only make one herbicide application per year, a pre-emergence application is probably a good choice. Many annual grass and broadleaf weeds can be controlled or suppressed with pre-emergence herbicides. If no spring seeding will take place, products containing pendimethalin, dithiopyr, prodiamine, and other pre-emergence active ingredients can be used for control of crabgrass, goosegrass, and especially foxtail. For situations in which breakthrough of annual grasses occurs, a post-emergence herbicide can be used. A few that are safe to use on fine fescues are Cethoxidin or Segment 2, Fluazafop or Fusilade 2, or Phenoxyprop, Acclaim Extra. Control of perennial grasses, sedges, and broadleaf weeds can be challenging in non-mowed fine fescue stands. If only a few single stalk weeds are present, such as horseweed or Canada thistle, they can be removed by hand or with trimming equipment. However, post-emergence herbicides are usually more efficient for reducing extensive weed infestations, such as the stand of quackgrass shown in this photograph. Some post-emergence herbicides will injure fine fescues, whereas others are relatively safe, so be sure to read product labels carefully for tolerant species before using in naturalized grass areas. Post-emergence grass herbicides that are effective in controlling perennial grass weeds include the ACCase inhibiting herbicides Fusilade 2 and Ornamec 170, Assure 2, as well as Segment 2 and Cethoxidin SPC. These herbicides are safe to use on fine fescues at label specified rates, but differ somewhat in the species of perennial weed grasses controlled. Non-ionic surfactants, methylated seed oils, or crop oil concentrates should be added for optimum efficacy. Caution should be used when applying these herbicides near native grasses such as little bluestem and switchgrass. Yellow nutsedge can be controlled with one of several different herbicides that contain sulfentrazone, such as Dismiss, Dismiss NXT, Solitaire, or Echelon 4SC. Halosulfuron, which include Sedgehammer or ProSedge, or Amazosulfuron Solero. Nutsedge herbicides are best applied around mid-June before tubers begin to mature. In our trials, Fusilade 2 at the 16 fluid ounce per acre rate provided the most consistent control or suppression of quackgrass among the ACCase inhibiting herbicides when applied in early summer and again in late summer. However, despite 2 summer applications, some regrowth from rhizomes occurred in fall. Quackgrass is one of the toughest perennial grass weeds to control, so it will probably take more than 1 year to achieve satisfactory control. Fusilade 2 is also the best ACCase inhibiting herbicide for controlling bentgrass that has invaded fine fescues. We have found good control in a single season with using spot treatments of this herbicide. This photograph shows what can occur when Fusilade 2 comes in contact with the little bluestem. Thus, be sure to keep away from this species when spraying perennial weeds. As previously mentioned, tall fescue is often considered a weed in pure stands of fine fescue. Our research shows that a late summer application of Segment 2 at the 28 fluid ounce per acre rate does a pretty good job in controlling Kentucky 31 tall fescue. Control was not 100%, but it was the best herbicide treatment in our trials. Fusilade 2 did not control tall fescue at all. Invasive broadleaf weeds can be controlled by one or more combinations of broadleaf herbicide active ingredients. One of the most tenacious and common broadleaf weeds in native areas, Canada thistle, can be controlled with post-emergence applications of clopyralid-containing products such as Confront or Lantrell, as well as a new product called Native Clean, which contains aminopyralid and 2,4-D. All these herbicides are very safe on fine fescues. Keep in mind that Canada thistle has extensive rhizomes and is a prolific seed producer. Thus, it has potential to produce new plants throughout the growing season. Follow-up herbicide applications are often needed for acceptable control of this species. Phenoxy and benzoic acid herbicides containing 2,4-D, MCPP, and dicamba, 2,4-D clopyralid and dicamba, as well as 2,4-D fluroxapyr and triclopyr, all give good control of a variety of broadleaf weeds in naturalized areas. This slide shows the results of applications of Native Clean at both the 28 and 34 fluid ounce per acre rates on Canada thistle in midsummer of 2020. Although the results were similar with Confront treatments, Native Clean worked a bit faster. We are going to monitor this test to see how much of the thistle population comes back in spring. Other herbicides of interest that we are currently researching at Penn State include the ACCase inhibitor clethodim, which goes by the trade name Tapout, as well as other trade names. It is currently not labeled for fine fescues in the United States. However, it is used to control poa annua and fine fescue turf in other areas of the world, such as New Zealand. It is labeled for a number of perennial grasses, as well as poa annua. It is also a seed head inhibitor, and in our trials, it causes slight phytotoxicity to fine fescues at low rates, with increasing injury at higher rates. We are also interested in looking at the ALS inhibitor metsulfuron, which goes by the trade name Manner. This is a broadleaf herbicide, a bit unusual for an ALS inhibitor and a sulfonylurea. It's a WDG formulation labeled for fine fescues at low rates, ranging from 1/4 to 1/2 ounce per acre. We have performed some trials with chlorsulfuron, trade name Telar. This is a perennial grass right-of-way herbicide. It controls perennial ryegrass and tall fescue. However, it is very phytotoxic to fine fescues, so it does not look like something we are going to explore any further. We also plan to look at the efficacy of a relatively new product called Sapphire, which is also an ALS inhibitor and a broadleaf herbicide. This slide shows the results of one of our phytotoxicity trials with clethodim, or Tapout. We looked at 3 different rates of this product: 32 ounces, 24 ounces, and 12 ounces per acre. The plot on the left shows seed head inhibition and some foliar phytotoxicity at the 32 ounce rate, whereas the plot on the right shows seed head stunting at the 12 ounce rate. This product is currently not labeled for fine fescues. Small trees and shrubs can be a real problem in infrequently mowed fine fescue areas. Mowing can help keep them suppressed, but some species keep coming back every year. Properly applied herbicide treatments to expose cambium in cut surface can keep trees from producing new stems. The procedure for treating saplings or larger trees is to cut the stem off as close to the soil surface as possible. Then treat the stump immediately, all the way to the soil line with a triclopyr oil-soluble formulation. 2 products that can be used for this purpose are Garlon 4 concentrate and Pathfinder 2. Triclopyr is not soil active, so soil treatments will be of little use. To summarize, naturalized grass stands can enhance the beauty of golf courses and create interest and challenges for golfers. Selection of fine fescue seed mixtures and seeding at the correct time of year are paramount for successful establishment. Non-mowed grass stands should be placed in areas that do not receive irrigation or fertilizer and where play will not be slowed. Mowing should occur at least once per year and possibly more frequently to suppress weeds, shrubs, and tree growth. Weed management is a significant challenge in maintaining naturalized grass areas, and managers should devise a plan for troublesome weeds and scrutinize herbicide labels for safety to fine fescues.
Okay. Pete, thank you for the presentation. I think we have time for questions for all three of our speakers, if anybody has any. How long did it take you to put that presentation together, Pete?
Too long.
I know.
I think it's better to just wing it sometimes.
No, it was very soothing. Like it was, you know, everything was planned out, where I'm just totally winging it. So we'll let people have time to ask questions. But Brad, if you want to maybe make a couple just final announcements about pesticide credits and how that works, and make sure everybody knows. And then if we don't have any questions, we'll end the session. But we still have a few minutes.
Wonderful, great. It's great to have the speakers here with us today. Good presentations for your pesticide certification credits. If you haven't done so already, please put the name in the chat box. Go ahead and place your name in there, the state of residence or the state that your certification's at, and also your certification number would be great. And then we will take care of getting that information then submitted to PDA for certification credit. So again, if you haven't already done so, name, state, and certification number. So we do, John, we do have a question. Will the presentations be accessible to view from the recordings?
Yeah, I assume we'll put them up on our YouTube page or something, and make them available to those who registered for it, or somehow make it available. I think from a pesticide credit standpoint, you had to be in here live, but I think that we'll make these available afterwards. I will make a couple announcements as well. First, tomorrow, we have Jenny Chris from Penn State. It's going to be talking about pesticide formulations. Jeff Borger will be talking about safely applying pesticides at different stages of growth. And Dr. McGraw will be back to talk about earthworm management. So that's what's on tap for tomorrow. And I did want to share my screen and mention, because the Turf Club told me to do this. The Turf Club is doing a pre-sale of new merchandise. I know a lot of people have been asking about where to get Turf Club apparel and stuff. And so they're going to have this open through, I don't know when, end of January. And then these items will be purchased and shipped out in late February. So if anyone's interested, you can now go on psuturfclub.com is their website. You can link to the store from there. So I thought I'd give them a shout out.
Cool. Excellent. Seeing
no other questions, I'm going to stop the recording. We'll hang out for a few minutes in case anybody does have a question. But thanks everybody for coming. It looked like it was a pretty good turnout, and we'll hopefully see people again tomorrow.